we are moving on to CO2, which is estimating the root of a non-perfect square. We talked about this term in CO1. What did we learn about non-perfect squares in CO1? Henry?
That means that they are irrational numbers.
They're all irrational because their decimals go on forever. Okay? They're all irrational because their decimals go on forever. So what our goal today is to be able to look at a non-perfect square and estimate its decimal value, essentially round it. And we're going to go near 10 today. Okay? What?
This is better. Where? Just like stomp on it.
Don't step on it. Eat the spider. No, let Grayson deal with it.
Who's that? I'm gonna.
That's good. We've got a spider situation over here right now.
You just killed it.
No, I do not.
How you doing? Nice to see you.
That's a cool box.
Thanks.
Okay. Are we all good now?
Yeah.
Okay, good. So our goal today is to be estimating the roots of non-perfect squares. And the definition of a root is a number that, when multiplied by itself, gives you the original value. A number that, when multiplied by itself, gives you the original value. Sometimes words can be hard. Words can be confusing. So I think I mean, you know what a square root is, right? But applying it to this definition here, like a number that, when multiplied by itself, gives you the original value. Let's say the original value is 100, right? What number times itself gives you the original value of 100?
10.
That is why 10 is the root of 100, right? 100 is the original value, the root of that is 10. And you show it's the root by using the root symbol. Not to be confused with that division symbol that you learned way back in the day, right? With the root symbol over a check mark and a curved side there. A perfect square is a number with integer roots, such as 100. Its root is 10. Integer. 225. Its root is 15. Integer. Okay, those are the perfect squares. A non-perfect square is a number, and this is going to be our focus today, a number with irrational roots. Decimals that go on forever. Okay? And why certain numbers are perfect squares and others aren't, it really comes down to this title. Like it's perfectly named. Perfect square. Let's take a small perfect square like 9. Okay? Can you arrange 9 dots to make a square?
Yeah.
Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That is why 9 is a perfect square. You can have a 3 by 3 square. 16 is a perfect square because it has a 4 by 4 square. 100 is a perfect square. It would be 10 by 10. A number like 8, a non-perfect square. Can you arrange 8 dots to form a square?
No.
No. You could do a rectangle, right? But you can't do a square. Okay? You can't arrange 15 dots to make a square. You can do a 3 by 5 rectangle, but it can't be a square. Okay? So the reason why they're perfect squares and non-perfect squares is literally whether or not you can make a square with that number of dots. Okay. Questions so far? All right. This is like the appetizer. Time to get to the second appetizer here. We're going to write out the perfect squares and their roots just so you have them. You are not allowed to use a calculator on this section of the test. I will, however, allow you to use this table on a help sheet if you write it there. Okay? So these are going to be helpful for what we're going to be doing today. And obviously the reason why you can't use a calculator is because, I'm not testing whether or not you can type root 51 into a calculator and get the answer, right? But you can use this if you write it on a help sheet. So, the first perfect square is 1. What's the root of 1? 1. Good start. The next perfect square is the root of 4. Its root is 2. The root of 9 is 3. The root of 16 is 4. The root of 25 is 5. The root of 36 is 6. The root of 49 is 7. The root of 64 is 8. And all the way up to 100, which is 10. What's the next perfect square after 100? Lucas?
121.
121. And then
144.
144, which is 12. And then
169.
169, which is 13. And then
196.
196, which is 14. And then
225.
225, which is 15. So those are those are all the perfect squares I expect you to know. You're probably already pretty fluent up to 100. Maybe some of you are rocky on those last 5 there. But those are the ones that you should know. Okay? And again, those are the perfect squares. Notice their roots are integers, and we don't skip any numbers from 1 to 15. So here's what we're doing today. Someone give me a non-perfect square that is between 1 and 225. Madden?
41.
41. The root of 41. Okay? If we're going to estimate that value, it's important to know the perfect squares, because that kind of gives us a little range as what it could be between. Okay? If the next smallest perfect square is 36, the next largest perfect square is 49, knowing that the root of 36 is 6, and knowing that the root of 49 is 7, this gives us a range, right? Root of 41 is somewhere between 6 and 7. Okay? What would you say? What's a reasonable estimation here for the root of 41? Kyle? 6.5. I'm going to challenge that one in just a little bit. It's not the worst answer you can give, but I'm going to challenge it. Yeah? Go ahead, Lucas.
6 and 5/13.
We'll go in fraction form. We're just going to stick with decimals here. Okay? Stick with decimals. And the reason why he said 5/13, which is excellent, is because a difference of 13 between 36 and 49, we're 5 away from 36, so 5/13 from the next perfect square. But we're just going to stick with decimals here, okay? But that was excellent. Rowan?
6.4.
6.4, I would take that one.
6.3.
6.3.
He said what I was going to say.
I'd even take 6.2, I'd even take 6.1, but why would I not take 6.5? Why do I be such a stickler about not 6.5? And why 6.4, 0.3, 0.2, and 0.1?
Because that one was N.
Well, all of these are technically ending, right? 6.4, we're just rounding it, you know, but why would I not even accept 6.5 as an approximate answer, as a rounded answer? Whereas I would accept 6.4, 6.3, 6.2, or even 6.1. You know.
It's not the exact middle.
Right. So what I want you to get to notice here is that, 41 is closer to 36 than it is from 49, right? It's only 5 away here versus 8 away from 49. Therefore, your answer should be on this side of half. Okay? This side of half. Thus, 6.1, 6.2, 6.3, even 6.4. Okay? Questions on that? Nah. Row.
Do you want
Grace.
Can I go to my band?
Sorry?
Can I go to my band?
Yes. No, I can't deny such a request. Fine arts are important. Give me another.
Well, you
Non-
should do no I wanted.
Not for a band lesson. Fine arts matter. Number square. Go ahead. 45. Let's get one a little bit further away from.
Oh, you want me to go again?
Yeah. How about 145? Can we do that one?
Sure.
145. Okay. So for 145, again, our strat here is we're looking for those two perfect squares on either side of it. So you look at your little chart up there, and you see where's 145 fall between. Okay, I see 144. That's the next smaller one. 169 is the next bigger one. And so we've got 144 is 12. Root 169 is 13. That means that 145 is somewhere between those two numbers. Most of you would probably put what as an answer, Christian?
12.1.
12.1, right? Because it's super duper close to the root of 144. It's only 1 away versus 24 away from 169. So 12.1, best answer, but I would also accept 12.2. I'd also accept 12.3. And if the Packers won that week, I'd also accept 12.4. Because I'd be in a dandy mood. Yeah?
Can I write 12.05?
If you want to go to the nearest hundredth, that be my guest, fine. But I'm only going to require 10. Any other questions? Okay, I would like you to do the first. I want you all four. You know, let's just start working. I'm gonna let you work. Let's see. Well, first I gotta capture that. Okay. Save that. Oh boy. There we go. Okay. So you can start working on these 4 here, then we'll kind of take questions, talk about it. I'll pause the video. There is some more stuff on the backside that I would like to talk about before the day's over. So you can start here. See if I remember how to pause. Hold on. Pause.
So we can use
Pause.
Yeah, for this part. It says
Pause. Resume. Here we go.
What? Challenge.
So just seeing how things are going so far. Root 51, what did people get for this one? 7.1, 7.2, 7.3, 7.4. Anyone have questions on?
Answers right now?
Yes, we're going over answers for the first few, the first 4. Questions on how we got those? Root 40, root 49 and root 64 are the perfect squares you should have used, so you know it's between 7 and 8, and that's where we get 7.1 or 7.2. Root 140, what'd you come up with here?
11.8.
11.8, 11.9, 11.7. Yeah, basically you're looking at root 121 and root 144, meaning that it's between 11 and 12, right? Root 140 is much closer to root 144 than it is to root 121. Therefore, it's going to be closer to 12 than it is to 11. And that's where people got 11.7, 11.8, 11.9, somewhere in that range. Okay?
What about 11.6?
11.6, I'll accept that one too. Root 14, what'd you come up with here? 3.8, 3.7, something like that. Root 9 and root 16 are your roots, so you know it's between 3 and 4. Closer to 16 than it is to 9, so that's where 3.6, 3.7, 3.8, 3.9, any of those will be fine. Finally, root 92. We've got root 81, root 100, between 9 and 10. 92 is 11 away from 81. It's only 8 away from 100, so it's a little bit closer to that. So it's going to be a little bit closer to 10, which means 9.6, 9.7, 9.8, even 9.9, even though it's probably closer to 9.6. Again, all I care is that you're on the correct side of the path, is basically it. 9.6, 9.7 is probably the best answers, but, okay. I have some questions on the negative ones. The negative ones actually don't change anything, right? Just make your answer negative when you're all done. Because what this is asking for is the negative value of the root of 215. So if you got 14.7, is that what you've got? 0.6, 0.7, something like that? Just make your answer negative, and negative 14.7 is what you would get. Questions on that? Yes?
Why'd you put the negative outside the root instead of inside the root?
Because inside the root, we run into problems. Because if I were to ask you, actually I said we're not going to get to this today, apparently we are. If I were to ask you for the root of -9, what this is asking you is what number times itself equals -9. Why is that a problem?
Because you can't. It's negative.
Because you can't, and when
So
I put
many
it,
Judes in the class, I'll respond. Yeah, Jude, why is that a problem?
It's not possible.
yeah, it's not possible.
Why? Something times itself that equals -9. Why is that not possible?
Oh.
Do you know, Jude? No? Henry?
It's because when you multiply -9 plus -3 plus -3, two negatives equal positive.
Right.
It's not possible.
If you think the answer to this is 3, well, 3 times 3 is +9, so that doesn't work. If you're thinking, oh, it's got to be -3, well, -3 times -3 is also +9, so that doesn't
Possible
work.
to get this correct.
So this you'll deal with this more in Algebra 2, but some of you may get this on your math test Monday. This is where mathematicians had to meet at like the local, I don't know, Arby's or something like that.
Arby's,
Maybe?
yeah.
Like, what do we do? What do we do when we have a negative sign in the root? And someone said, you know what? Let's just imagine there's an answer. Let's just pretend. And so, if you've ever heard of an imaginary number, this is where it comes from. The correct answer to this, the root of -9, is 3i. Which means that if it did have a root, it would be 3, but it really doesn't. But we'll just imagine it does, because otherwise we don't know how to answer the question. Okay? It actually gets much more mathematical than that, and you'll learn about that in Algebra 2. But for our purposes here, and if you see it on the map test, the root of a negative number is the root, followed by a lowercase I, and that means it's imaginary. Good question.
Reimagine.
Alright, the next page, you've got some stuff that we haven't talked about yet. This top part is similar to what we did. This section here, it says, write the value of each decimal using a square root. I'm essentially going the other direction now. If I give you 7.1 as a decimal, I want you to approximate what the root, or what the original number was that would give you that root. So you're kind of thinking, okay, 7.1, I know that 7 squared equals 49, so 7.1 is going to be about the root of 50. 4.5 here. Okay? We know that 4 squared is 16. 5 squared is 25. What number is halfway between about 16 and 25? 20.
What about 20.5?
21. We don't want to put decimals inside of a root. If you did, I wouldn't mark it wrong, but root 20, root 21, either of those would be good approximations. 8.2. Well, I know that 8 squared is 64. 9 squared is 81. What number would 8.2 be approximately? 67, 68, 69, anywhere in there.
66?
Sure, why not? Okay, so this section is you going the other way. It's you going backwards. I'm giving you the answer, you give me the original root, or the original value. I should say I'm giving you the root, you give me the approximate original value. Okay? Then the word problems. Because what math homework would be complete without some word problems? When will you actually use this stuff? Okay, this little globe here, like, hey, I'm the real world. And this is where you can actually use some of the math that we talked about. It says, through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot to be a square with an area of 200 square miles. So you've got this square, and the area of the square is 200. The length and width of the plot, however, have faded. So you don't know what the length and width of the plot of land are. You do know the area though. Approximately how many miles long and wide is the plot of land? Yes, the fact that the square is important because what do we know about area and length and width and squares? They have the same thing, right? So what we're looking for is some number times itself
Roughly.
that equals 200. right? Because if it's a square, which it is, then something times itself has to equal 200. Now, we're going to get into a little bit of equation solving today. You remember opposite operations from last year? Right? Why are we perm DOS people? Because what's the opposite of an exponent?
Square root.
A root. To solve an equation like this, you're going to root both sides. And n is going to be the root of 200. You now know how to approximate this. Right? What number times itself is going to give us approximately 200? What do you think? Yeah.
14 point, like 1 or 2.
14.1, 14.2, something like that. Okay? So this is where you might actually like apply something like this in the hey, real world.
Hey.
The next one, a square bulletin board. Again, that's important. Square bulletin board is an area of 80 feet. Estimate the perimeter of the bulletin board. So I'm asking you to essentially do the same thing as this one, right? If you've got this bulletin board, that's a square. The area is 80. You want to figure out what the length and the width are. That would give you an area of 80. I'm asking you to go one step further. Once you find the length of the side, what would the perimeter be? Perimeter, remember, all sides added together, yes.
Or could we just do the answer times 4?
Would also work. A backyard in the shape of a square is 34 feet of fence surrounding it. What is the area of the yard? So again, square, important. I give you the perimeter, right? 34 feet of fence surrounding it. That would be perimeter, not area here, perimeter. And I ask you to find the area of the yard. And finally, we will talk about this on Tuesday. Or do you want to talk about it now? There are other types of roots other than the square roots, which is why in the 5-card challenge, if you use a square root, you have to have a little 2 there. We don't write it, but technically, when you take the root of 81, there's a little 2 up here to tell you it's a square root. Because square roots are by far the most common root, we don't actually write it there because we're lazy. But it's there, okay, girls? Which means that you can have other numbers there to talk about other types of degrees, okay? If you have the cubed root of 8, I don't know how well you can see this on your paper, but the cubed root of 8 equals 2, because in this case, it's saying what number cubed is 8. What number times itself gives you the original value. So a square root is just what times itself. A cubed root is what cubed, or what times itself times itself. The cubed root of 27. What times itself equals 27?
Me.
Not me.
3?
3. 3 times 3 times 3 equals 27. Therefore, the cubed root of 27 equals 3. Okay? The cubed root of 125. What times itself equals 125?
5.
5. 5 times 5 times 5. Therefore, the cubed root of 125 is 5. How about the fifth root of 32? What times itself equals 32? 5 of them. 2. 2 times 2 times 2 times 2 times 2. Therefore, the fifth root of 32 is 2. It takes 5 of them, all multiplied together to get 32. Finally, the fourth root of 10,000. What times itself, 10 times 10 times 10 times 10 is 10,000. Therefore, the fourth root is 10. So, you might see this on your math test Monday also. Now you kind of know how to handle it. But this CO2 is due on Tuesday. Monday, because we're going to take whatever, whoever doesn't finish their math test in the first hour, you'll finish it during math.
I have a very important question.
And really, you should not be finishing your math test during the first hour if you are adequately showing work and doing all that stuff. It's 43 questions. It should take you longer than an hour. Yeah.
What is your favorite lesson?
Well, let's do the outro first. Folks, can we sit down so I can do the outro? And then you can... do you remember what your role is here?
Yes.
Okay? With gusto. That's how you math.
Remember to like and subscribe.